All right, let's take a nice relaxing video and just talk about intercepts for a little bit, because these are more straightforward than a lot of things that we've been dealing with in this section. Recall, the whole idea about an x-intercept is it's the point where y equals 0. And the y-intercept is just the point where x equals 0, right? These intercepts are just where they hit the axis. X-intercept is x-axis. What's a point on the x-axis? Well, it has a y value of 0. That's how it all connects together. So finding intercepts for rational functions isn't too bad. Just the big thing to watch out for is to make sure the x-intercepts are in the domain. We'll see what that means when we do this first example. Example number 5. Find the intercepts of the following. Part A. F of x equals x minus 2 times x plus 3 divided by x minus 1 times x minus 2 times x minus 5. So this is really nice. It gives it to us entirely factored. Okay. That is nice. You'll see why that's nice later. So the x-intercept is when y equals 0. That's when 0 equals x minus 2 times x plus 3. So my goodness, Jason, how the heck are we going to solve this? Well, if we ever have a variable in the denominator, anytime we have a variable in the denominator, we solve it by getting rid of that denominator, multiplying by the LCD. So we're going to multiply by the LCD here on the right and on the left. And the left-hand side is great. You multiply a polynomial by 0, that left-hand side is still 0. And the right-hand side, they cancel, and we're just left with, oh, okay. So when we're finding intercepts of a rational function, we really only have to look at the numerator. All right. So we're going to get the intercepts at x equals 2 and negative 3. The problem is, of course, that x equals 2 is not in the domain, right? When x is 2, we're dividing by 0. There's also a factor in the numerator that tells us that x equals 2 is a removable discontinuity. All right. It's not an intercept. So watch out for that. Our only x-intercept is x equals negative 3 here. So you basically just only have to look at the top for x-intercepts. But if you ever forget, just solve it this way. That's what I'm going to be doing. All right. So one of our x-intercepts, again, is, I already forgot it, x equals negative 3. And again, y equals 0. The y-intercept is just when x equals 0. And that's a bit messy here, but all you have to do is plug in 0 into this function. So when you plug in 0, you're going to get 0 minus 2, 0 plus 3, over 0 minus 1, times 0 minus 2, times 0 minus 5. And again, please don't be lazy. When you're finding the intercepts of this function are the same as the intercepts of this function, but the functions themselves are not the same. So you can kind of get away with doing it, but be very, very careful with your math. If you say something that's not true, you might get docked points. So even though the intercepts are the same, just be very, very careful with your logic. The functions themselves are not the same. So this is going to be negative 2 times 3 times negative 1 times negative 2 times negative 5. Here, we could cancel, right? Common factor. And we're going to get 3 over positive 5 is our y-intercept. So that gives us our x-intercept and our y-intercept, and we check our answers with Desmos. Always helpful to check your answers. X minus 2 times x plus 3. Oh no, not again. Divided by, here I'm going to add another set of parentheses. It won't actually matter, but it'll make it look nicer. X minus 1 times x minus 2 times x minus 5. What do the intercepts look like for this function? I have to graph the function first. So, where does it hit the x-axis? -3, comma 0. And where does it hit the y-axis? 0 and 3/5. All right, and again, it's kind of hard to see here, but it does fall below the x-intercept, or below the x-axis. It is only that one x-intercept, and there is still that asymptote. But you can look around a little bit, but you won't find another x-intercept. This one's kind of hard to see it though. Let's do another one. Part B. The reciprocal, find the intercepts of the reciprocal squared function that is shifted right 3 units and down 4 units. So remember your function transformations. All right, so this is starting with the reciprocal squared function. And then right 3 units means we add a 3. Oops. Means we subtract a 3 from the inside of the function. And then down 4 units means subtract 4 from the outside of the function. We are looking for the zeros of this function, the x and y intercepts. So here, you kind of have two options. If you want to solve it the same way that we did the last one, you're going to have to get it in the same factored rational form. But you don't have to. Again, the x-intercept is when y equals 0. And we can just solve this with the same logic that we did the last problem. Our variables in the denominator, and we don't like that. Now, how do we get our variable outside of the denominator? Multiply both sides by the LCD. X minus 3 squared. Now the left-hand side, 0 times any number is 0. That was the left-hand side. The right-hand side, we have to distribute. On the first distributing on the left, they cancel completely, or just left with 1. Minus 4 times that LCD. Now this is a quadratic equation. We can solve it. It might be a bit of a pain because of a few things, but we can solve it. The most straightforward method is to get it. October, you better stop that right now. Got a troublesome kitty on the loose. The most straightforward way to solve this is to FOIL this out and get this in general form and use either the quadratic formula or factoring it. But it's actually already in the form for completing the square. So this one we can take a shortcut if you can see it. Otherwise, FOIL it out, collect like terms, quadratic formula, or factor. But watch this out. Anyone remember completing the square? We can add 4 times x minus 3 squared to both sides. And that gives us 4 times x minus 3 squared equals 1. If we get the squared term by itself, then we can square root both sides. Divide both sides by 4. And now take the square root of both sides. Don't forget the plus or minus when you square root both sides. And that'll give us that x is equal to 3 plus or minus 1/2. So that's 2 answers. Let's write them both. Our x-intercepts are 3 minus 1/2 and 3 plus 1/2, or 2.5 and 3.5. And let's just make sure that these are in the domain. Can we plug in 2.5 or 3.5? Yeah, we can plug in both. The only thing we can't plug in is 3. There's a vertical asymptote at 3. So those are our x-intercepts. And again, let's copy down our function. Was it +4 or -4? It was -4. For the y-intercepts, that's just when x equals 0. This one's usually much more straightforward. Just plug in 0 and type it into a calculator. There's going to be a 1/9 minus 4. It's 1/9 minus 36/9. That's a negative 35/9. Or you can find a decimal approximation as well. So our intercepts are 2.50, 3.50, and 0,35/9. You can get a decimal approximation too. That would be fine. Let's check our answers here. First off, our answer should look like reciprocal squared function shifted to the right 3 units and down 4. Right, that is what our function was. So this is a reciprocal squared function. Is it right 3 units? Yep, that's where the vertical asymptote is. And was it shifted down 4? Yep, you can see the horizontal asymptote is now at -4. Y-intercept? -3. Well, what did we say? We said -35/9. Hey, that's the same number. Very good. X-intercepts? 2.5, 3.5. We're good to go. I'm pretty sure we're done. Pretty sure we're done with this video, but my notes are actually a little bit unreadable right now. My notes have been sat on. I'm pretty sure this is the end of the video, so take it easy. Have a good day. Let me know if you have questions.